Today we are going to discuss how to write enthalpy of formation equations. Standard enthalpy of formation equations. For example, 2Al plus 2Al plus 3 by 2 O2 gives rise to this is a solid, this is gas, gives rise to Al2O3 solid. Al2O3 solid. So this equation represents enthalpy, standard enthalpy of a formation of Al2O3. Okay, enthalpy of standard enthalpy of formation is equal to in such case minus 1675 kilojoules. Minus 1675 kilojoules per mole. Okay. Similarly, enthalpy of formation of water. So, H2 gas, H2 gas plus half O2 gas gives rise to H2O liquid. H2O liquid. Enthalpy of standard enthalpy of formation is equal to minus 285 kilojoules per mole. Minus 285 kilojoules per mole. Okay. Similarly, standard enthalpy of formation of methyl alcohol. C graphite, C graphite plus 2H2 gas plus half O2 gas gives rise to CH3OH liquid. CH3OH liquid. Enthalpy of formation of methyl alcohol. Standard enthalpy of formation of methyl alcohol is minus 238 kilojoules per mole. Minus 238 kilojoules per mole. Minus 238 kilojoules per mole. Okay, one problem. H2 plus Br2 gives rise to 2HBr. H2 gas plus Br2 gas, Br2 liquid gives rise to 2HBr, 2HBr gas. Heat of reaction is equal to heat of reaction is equal to heat of reaction is equal to minus 36 minus 72 kilojoules, minus 72 kilojoules. What is enthalpy of formation of HBr? Enthalpy of formation is always expressed for a mole. Enthalpy of formation is always expressed a mole. So, for 2 moles, enthalpy of reaction is minus 72 kilojoules. So, enthalpy of, in such case, enthalpy of formation of HBr is not equal to enthalpy of reaction of HBr. So, enthalpy of formation is always expressed for is always expressed is always expressed for 1 mole of HBr. Okay, therefore, enthalpy of formation of HBr is equal to enthalpy of reaction divided by 2, that is equal to minus 72 divided by 2, that is equal to minus 36 kilojoules, that is equal to minus 36 kilojoules. Okay, next, JEE main, JEE main. Enthalpy of formation of HF HCl and HBr and HI. Enthalpy of formation of HF HF is minus 271 kilojoules, minus 271 kilojoules. HCl is minus 92. This is minus 92 kilojoules, minus 36 kilojoules. Whereas HI is 26.20 plus 26 kilojoules. So hydrogen fluoride and HCl and HBr exothermic compounds. Exothermic compounds, while HI is endothermic compound. Since enthalpy of formation of HI is endothermic compound, since during formation of HI, heat is absorbed. Heat is absorbed. So HI is endothermic compound, while HF, HCl, and HBr are exothermic compound. So enthalpy of formation of HF is more. Enthalpy of formation of HF is more. In such case, a large amount of heat energy minus 271 kilojoules heat energy is released. So HF is more stable. HI is less stable. Similarly, enthalpy of formation of NAF, NaCl, NABr, and NaI. So enthalpy of formation of NaF is minus 573, minus 573, minus 411 kilojoules, minus 360, minus 360 kilojoules, and minus 287 kilojoules. Minus 287 kilojoules. So the most stable compound is NaF. The least stable compound is NaI. Greater the enthalpy of formation of value, higher will be the stability. Greater the enthalpy of formation, higher will be the stability. Okay, please write down. Next, enthalpy of formation of PCl3 and PCl5. Enthalpy of formation of PCl3 is minus 319 kilojoules. Minus 319 kilojoules. This is minus 440 kilojoules. So PCl5 is more stable than PCl3. PCl5 is more stable than, thermodynamically more stable than PCl3. PCl5 thermodynamically, PCl5 is more stable than PCl3. Similarly, enthalpy of formation of SnCl2 and SnCl4. SnCl4. Enthalpy of formation of SnCl2 and SnCl4. SnCl2 minus 325. Minus 325. SnCl4 is minus 511 kilojoules. So thermodynamically SnCl4 is more stable than SnCl2. Thermodynamically SnCl4 is more stable than SnCl2. Similarly, sulfur dioxide and sulfur dioxide. Sulfur dioxide and sulfur dioxide. Enthalpy of formation of sulfur dioxide is minus 296. 296. This is minus 395. 395. So thermodynamically, sulfur dioxide is more stable than sulfur dioxide. Okay, key point. Diamond, bromine, H gas, Cl gas, SiH4, NO gas, NO2 gas, HI gas have positive enthalpy of formation. Important. Bromine liquid, bromine liquid, SiH4 gas, bromine liquid, SiH4 gas, C diamond, and oxygen gas, chlorine gas, chlorine gas, NO gas, NO gas, NO2 gas, NO2 gas, HI gas, HI gas have enthalpy of formation is equal to positive. Standard enthalpy of formation is equal to positive. Okay. Similarly, enthalpy of formation of methane, enthalpy of formation of methane, ethane, okay, etc. is equal to negative. Sorry, positive, negative. Enthalpy of formation negative. These are exothermic compounds. Enthalpy of formation of benzene is positive. Enthalpy of formation of benzene is positive. Okay. So increasing order of enthalpy of formation. Increasing order of enthalpy of formation. Methane less than ethane. Ethane less than propane. Propane less than butane. As the number of carbon atoms increases, enthalpy of formation increases. This is 74. Enthalpy of formation minus 74. This is minus 84, minus 84, and minus 103. Okay, this is minus 126. So, as the enthalpy of formation, as the number of carbon atoms increases, enthalpy of formation increases. Negative sign only indicates that releasing of heat energy during the formation of compound. Okay, next. Fe plus find the enthalpy of reaction. Find enthalpy of reaction for find enthalpy of reaction for Fe2O3 solid plus Fe2O3 solid plus 3H2 gas gives rise to 2Fe solid plus 3H2O. Fe2O3 solid plus 3H2 gas gives rise to 2Fe plus 3H2O. Okay, enthalpy of formation of H2O is enthalpy of formation of H2O is equal to minus 285 kilojoules. Enthalpy of formation of H2O is minus 285 kilojoules. Enthalpy of formation of Fe2O3 is minus 823 kilojoules per mole. Okay, find enthalpy of reaction. Find enthalpy of reaction. Therefore, enthalpy of reaction is equal to sum of enthalpies of formations of products minus enthalpies of sum of enthalpies of formations of reactants. Okay, product 2 into 0. This is element. For elements, enthalpy of formation is equal to 0. For elements, enthalpy of formation is equal to 0. Okay, 2 into 0 plus 3 into minus 285 kilojoules. Okay, minus for Fe2O3 minus 823 kilojoules plus 3 into 0. For elements, enthalpy of formation 0. Okay, therefore enthalpy of reaction is equal to minus 33 kilojoules. So this reaction is exothermic reaction. So this reaction is exothermic reaction. And another problem. Enthalpy of formation of element is equal to 0. Enthalpy of formation of element is equal to 0. So enthalpy of formation of H2 is equal to minus 285, minus 823. Enthalpy of reaction is equal to sum of enthalpies of formation of products minus sum of enthalpies of formation of reactants. So substitute here and you get answer minus 33 kilojoules. Okay, next. Second problem. CaCO3 gives rise to CaO plus CO2. CaCO3 gives rise to CaO plus CO2. Find the enthalpy of reaction. What is the enthalpy of reaction? Question mark. Given that enthalpy of formation of CaCO3 minus 1206. This is minus 1206. CaO minus 635. Minus 635. This is minus 395 kilojoules. 1206 kilojoules minus 635 kilojoules minus 395 kilojoules. What is the enthalpy of formation? What is the enthalpy of formation? Okay. So enthalpy of reaction is equal to sum of enthalpies of formations of products minus sum of enthalpies of formations of reactants. Okay, enthalpy of reaction is equal to minus 635 minus 395 minus of minus 1206. Okay, find the answer. Minus 1206. Okay, find the answer. Minus 635 minus 635 minus 395 plus 1206. Okay, this is the answer. Okay, next. C graphite plus oxygen gas gives rise to CO2 gas. Enthalpy of reaction is equal to minus 385 kilojoules. What is enthalpy of formation of carbon dioxide? So enthalpy of reaction is equal to sum of enthalpies of formations of products minus sum of enthalpy of formation of reactants. So therefore enthalpy of reaction is equal to product carbon dioxide, enthalpy of formation of CO2, minus enthalpy of formation of carbon graphite plus enthalpy of formation of oxygen gas. So enthalpy of reaction minus 385 is equal to enthalpy of formation of CO2 minus 0 plus 0. This is element and this is element. For C graphite, enthalpy of formation is 0. For oxygen is element, enthalpy of formation is equal to 0. Therefore, enthalpy of formation of carbon dioxide is equal to minus 385 kilojoules. That is equal to enthalpy of reaction. So, for this reaction, enthalpy of formation is equal to enthalpy of reaction. Enthalpy of formation is equal to enthalpy of reaction. Okay, this is about enthalpy of formation.